All right, picking up here at 14, we have a table of values, and we'll look at what we can tell from this table of values. So I just want to highlight a few items on here. Uh, so it's giving us some intervals and telling you some different values in between intervals. But what I would start with is, where is the derivative 0 or undefined? Well, it's undefined and it's undefined. So those are possible critical, or those are possible maxes and mins. They're definitely critical numbers. And so then on either side of that, you could take that information and tell what's going on. Now this graph starts at 0 and or it starts at -6 and goes to 6, but we don't have information on the other side over here. So we only have from x goes to 0 to 6. I'm not sure why they didn't put that in there. If you look at where the second derivative is 0 or undefined, that would tell you possible inflection points. Also, it's 0 here. So we have possible inflection points here and here. And then they're writing this a different way than we do. So if you remade this table with 0 to your interval from 0 to 2, and then your interval from 0 to, or from 2 to 4, we could just skip that middle column. We know these are, we would just be looking at, we like to write an interval notation. So if the slope goes from undefined to positive to positive to positive to undefined to negative, that means it's increasing, 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 increasing. There's some kind of shelf or something, and then it's decreasing. So there'd be a relative max right there. Most likely they're going to be all numbers in this table. This is kind of just getting you to check it out. But we do have to make sure that you test. Don't just say because something's 0, it's a max or min. I know we're moving fast. And the copy machine made copies funny. Somebody said that they do always appreciate when I do that. So there you go. There's your appreciation. Implicit differentiation. Just remember, every time you take the derivative with respect to y, you add a dy dx. So for this problem, you'd take the derivative 2x. The derivative of xy is a product rule, so it would be x times dy dx plus y times x equals 0. Then you plug stuff in. This will show its head different times. Sometimes they will give you dy dx. We saw when you get to take the sample test, if they give you dy dx, when you take the second derivative, you might have to plug this back in as a substitution item. So always go back to what was given to you. Can I substitute anything in to solve? Differential equations then often lead to slope fields. So it says sketch a slope field for the given differential equation on the 12 indicated points. So I think that's the x and y axis there. You'd just make a table of points, and instead of an x only value, you put an xy there, and then all we need are the slopes. And so you go through and plug your points, and you look for patterns. Is the slope all the same at one place? If they give you a slope field, think about putting things back into a table to help you figure some stuff out. Again, I'm going to encourage you to do that multiple choice practice test because it will have that. So all of these differential equations have to do with slope fields and slope. That's what they are. And then you get down to here, it says solve the differential equation with the initial condition. To solve a differential equation, you're going to integrate. You want to get the x's with the x's and the y's with the y's, and there's some more examples of that. This is dy dx, so it's the same as f prime, so a little more advanced topic, but x minus 1 dx, and then you integrate. And the c is how we're going to find the initial condition with c. This always goes with the x side. And you'll notice that takes us right into integration, indefinite integrals. Just noticing a couple things here, you would rewrite this one before you integrate. Anytime you have a power that's one more than the other, you want to reduce. So this, you rewrite this fraction, x to the third over x squared minus 3x squared over x squared plus x over x squared before you simplify. You can't integrate. There's not a property that says integrating when there's one more than the denominator. One less than the denominator is a natural log when you integrate, but there's not one more. One like this, you're probably going to need to do some algebra or do some substitution. If you know, okay, when I'm doing substitution, I always want to let u equal what's on the inside. So du equals 2x dx. It's a good time to practice. They will ask you about how you do u substitution in the multiple choice, and they're easy questions if you've been practicing u substitution. So again, usually a good rule for the u is to let what's on the inside be u, or in the case of an exponential or square root, let the exponent, in the case of e, let that be your u. Riemann sum, see if I can do this in the amount of time I have left on this video. Right-hand Riemann sum, left-hand Riemann sum, midpoint Riemann sum, trapezoid Riemann sum. I'm not going to do it for these problems. I'm just going to make a picture, and I'll go back and make an answer key for these problems, but I'm going to make a picture in general. So if you had a function, let's just plot our points. So some function right here. And if I am doing a left Riemann sum, I will do that in pink. I'm going to use 3 rectangles. Okay, we'll just count these as our intervals. A left Riemann sum starts on the function, the left side of the interval, and goes over. So the other thing that'd be ready to answer is, would be an underestimate or an overestimate. And our width would be whatever that value is. We just did one on the multiple choice where they had a table and the widths were not uniform. Okay. A right Riemann sum would be starting at doing the same interval, but starting at the right endpoint of the interval when you work this. So right over and down, right over and down, right over. So this would be an overestimate. Midpoint would be in the middle and down, middle and down, middle and down. And the trapezoid, my original points back on here, just means you're making trapezoids with the points you have and using your trapezoid formula. So average these two bases, multiply by the width. So if this was 2 and this was 5, the average of 2 and 5 is 3.5. Let's say that width was 4, 3.5 times 4. It's really a rectangle. You're turning your right trapezoid into a rectangle by cutting it off. But you can use your base 1 plus base 2 divided by 2 times height, whatever form of the trapezoid area you used when you were a kid. So this one talks about, you need to know those are the heights. Your trapezoid is really turned sideways, so the height of your trapezoid is really the width on the x-axis. And then, all of these Riemann sum things, we got tighter and tighter, got more and more rectangles, and eventually we got to where it led to the fundamental theorem of calculus, which will be the next video.